So these are taken from the old Math 12 book. They took these 2 units out because they are, insert whatever you want in there. Unintelligent, how's that? They're not irrelevant. They took them out because I have no comment why they took them out. But anyway, so reciprocal transformations. They used to have it in Math 11, and then I think it got taken out of Math 11 too, so then it just disappeared from the math curriculum. So we learned back in the first chapter that there were 2 cases when you had domain restrictions. What were they?
When you have a square root for your
When you have a square root or variables in the denominator. Reciprocal transformations generate, usually, reciprocals in the denominator. So for example, if I have the graph of x squared minus 5, and I do the reciprocal, first of all, what's the reciprocal? It's just 1 over the function. If it's already a fraction, you flip it, but it's 1 over the function. So the reciprocal of x squared minus 5 becomes 1 over x squared minus 5. What would be the domain restrictions here? Can anybody tell me the domain restrictions? Nobody said the right answer, so can't be anything. Okay, yeah. That's half of it.
Or negative 5.
You're really close. That's it. So if you were to solve this, you would say x squared minus 5 cannot equal 0. Move the 5 over. When you square root something, what do you need to remember? Plus minus. So it's plus minus the root of 5. Okay, so you got half. All right. Whatever makes the denominator 0 is a domain restriction. Now, what we're going to look at is what do those domain restrictions look like on a graph? Okay, because this is a graphing unit. So, and actually, before we do that, if I said, what are the y-intercepts of this function, the parabola? Y-intercepts are when what? Not x. Did I say y-intercepts? Oh, sorry. I want to know what the x-intercepts are. Thank you. You were right. X-intercepts are when y is 0. So if I put 0 into there, I end up with x squared minus 5. When you solve that, it's the same as this one over here. So you get x is equal to plus minus root 5. What do you notice about these 2 numbers? They're the same. The x-intercepts became your domain restrictions. Okay? So when you're graphing, if I have the graph of x plus 3, which is a linear line. They've drawn it there for us. What number are you not allowed to divide by? 0. So where y is equal to 0, i.e. the x-intercept, when you do the reciprocal graph, you generate what is called a vertical asymptote. The graph does not touch the vertical asymptote because the vertical asymptote occurs where your y value is 0, i.e. your x-intercept. Okay, that's where the vertical asymptotes occur. For right now, for this unit, there's also, if you look at the graph, it gets really, really close to, but never touches this line right here. This is called a horizontal asymptote. So the graph doesn't touch either one of those for now. And by now, I mean, no, this unit for sure. Can't remember if it happens later on, but in calculus, we'll see different things. But that's irrelevant for us right now. Okay, so horizontal asymptote for this specific unit, your horizontal asymptote is always y is equal to 0. That will change later on in the units, but for this unit, it will always be y is equal to 0, i.e. it is the x-axis. Okay, I will change that later on, but not in this unit. Okay, vertical asymptote is where the x-intercepts occur. Generated from X-intercept. Okay, now we're just going to practice graphing these things. So I need you to flip the page, please, to page 78. So 2 pages. Oh, hang on. This page, yes, page 78. Okay. So we have the graph of x cubed. I'm going to give you the graph of x cubed, all right? Here's the graph of x cubed. There's the graph of y is equal to x cubed. If I ask you to sketch the reciprocal graph, so that's 1 over this graph. So 1 over f of x. If f of x is x cubed, we're sketching 1 over x cubed. What are you not allowed to divide by? 0, right? And in this case, x equals 0 is that value. And if you look at the original graph, where's the x-intercept? At 0. So the x-intercept always becomes your vertical asymptote, which you represent with this dashed line. And that is x equals 0. What is always the horizontal asymptote in this class until I tell you later on it's not? 0. So that's the x-axis. So it's this. Okay. So we've got vertical and horizontal asymptotes. For now, you can't touch either. Okay, you never can touch, a graph can never touch a vertical asymptote, but you'll see if you get into calculus, you learn you can cross a horizontal, but that's irrelevant to us right now. You can never touch either for us right now. Okay? So we are doing 1 over. So if this, the original graph at this point has a value of 2, and I do the reciprocal, what's 1 over 2? A half. I just said it, right? So that point now moves to 1/2. If this is, what do these go up by? We'll just say 3s. If this is 3, and I take the reciprocal of it, where does it go to? 1 over 3. So it's down there somewhere. Now, if I say this point right here is at 1/2, and I take the reciprocal, what's 1 over a half? 2. So it gets bigger. Okay. Whoops. That's the original. Okay, so what this new graph looks like is you cannot touch the vertical asymptote, you cannot touch the horizontal asymptote. You can see that as if you pick numbers, x values that are smaller, or sorry, y values that are smaller than 1, like a fraction, a proper fraction, and you do the reciprocal of a proper fraction, you actually get a bigger number. Okay? So anything to this side of the graph is going to go up. Anything like big numbers like 3 or 5 or whatever, 1 over that actually gets smaller. So the graph looks like that. Looks like that. Why does this point stay the same? Yes.
1 divided by 1 is still 1.
Because it's at 1, and if you go 1 over 1, it's 1. Okay? That's only half the graph. Because you have this part of the graph to do. It does the exact same thing, though. All right? Right? This part of the graph, your invariant points at -1 this time because 1 over -1 is still -1. Anything less than 1 will be really big, i.e. it's going to go down here, and these like -2, 1 over -2 flips down here. So then the graph looks like this. And the red lines are your new graph, your reciprocal graph. All right. We're going to practice this again. Bottom of the page, please. So here's our functions. We're going to sketch the reciprocals. So first thing you do when you're sketching the reciprocal is to mark the vertical asymptote. Where do vertical asymptotes occur? X-intercepts when y is 0. So you find your x-intercept and you draw a vertical line, a dashed vertical line. Mark your invariant points. They occur, and I'm going to summarize this. They occur at plus and minus 1. So look at the original graph. Are there any points that go through the plus minus 1? That point there. And that point there. There is no negative ones in this graph. Then, what's your horizontal asymptote? Always 0, until I tell you later on. So for now, it's 0. So y is equal to 0. Okay, then you sketch your graph. You have to go through the invariant points, the green dots. You can't touch any of the asymptotes. So the only thing you can really do is this. So that is the 1 over f of x graph, the red one. So whatever makes the denominator 0 is a vertical asymptote, which is the x-intercept. Okay, next one. What do you mark first? X-intercepts. So your x-intercepts become your Vertical asymptotes. What is always your horizontal asymptote? 0. For now. And I'll just mark the vertical asymptotes at the numbers x equals 3, x equals -2. Where are your invariant points? What points don't change?
When it's at 1.
Plus minus 1. So find all your plus minus 1s. There's one there. They've drawn these nice lines, y is equal to 1, y is equal to -1. You won't usually have that. So anywhere the graph has a value of plus or minus 1, those points don't change. All right. Now you sketch the graph. There's 3 sections to this graph because there's 2 vertical asymptotes. Okay? So in this section here, you cannot touch any of the asymptotes. So the only thing the graph can do is go like that. And then I'll just do the one over to the right here, this one here. Same idea. You can't touch a vertical asymptote or a horizontal. So we come down, and it looks like that. Okay, the middle bit. Can't touch either asymptote, can't touch the horizontal asymptote, has to go through those 2 points. These are at 2. If you take the reciprocal of it, where does it go to? Or -2, I guess. -1/2. So they move to like there. So it looks like this. Yeah, I just can't draw a straight line. Straight enough. Yeah. So the purple is your 1 over f of x. All right. Here's your steps. I'll write on the next page. First step. Mark your X-intercepts. They become your vertical asymptotes, which I will always abbreviate VA from now on. 2. Horizontal asymptote. Asymptote. Your horizontal is always what? 0. So you mark that. Mark your invariant points. Invariant points occur at y is equal to plus minus 1. And then your 4th is sketch the graph. Okay. I only want you to do number 1, please. Yeah. All right, sketch number 1, or do number 1, please. And then we got another short lesson. And then we are done.
Yeah.
What's the name of one equation for the asymptote? Is it just being like
X equals whatever the x-intercept is.
Yeah, you're right.
No.